Okay, we're on. Okay, so yesterday, there's a little bit of a glare on there. Anyways, order of operation part 2. I hope you can see all this. Okay, I know, but it's just, I'm looking at it and it shows a glare. So yesterday we talked about order of operations. And
it was
the day before yesterday we talked about order of operations, right? Jeez, that's right, a long time ago. Order of operations, we figured out that operations are what again? Yes, Hunter.
Multiplication, division, addition, and subtraction.
Yeah, multiplication, division, addition, subtraction, all those. And we have to figure out what we do first, right? And as I was looking at the video yesterday, after I uploaded, I watched part of it, and I thought, you know, I really wanted to honor more of what Elizabeth said about this concept of going left to right. Because it's not really PEMDAS in that order exactly. It's P parentheses always first, exponents second, but then it's multiplication and division, multiplication or division, really, depending on which one comes first from left to right, right? So, and then it's addition or subtraction, depending on which comes first from left to right, okay? So that's really important because, I'll give you an example. I was sitting down, I was playing with this a little bit last night. So let's say you had something like, what did I do? Okay, 8 divided by 4 times 2 plus 15. All right, so I was thinking, you know, if you used PEMDAS and you didn't think of the left or right thing, right? And you just said, oh, well, I have to do multiply. PEMDAS says I have to parentheses, exponents, multiplication, division, addition, subtraction, right? So there's no parentheses, okay, none of those. There's no exponents, okay, don't have to worry about that. Multiplication, look at that. Multiplication, yes! Right, so if I did that first, what's 4 times 2? 8, okay. So now that's 8, so now I'm going to just rewrite this. 8 divided by 8 plus 15. What is 8? Now I says I got to do division. Now what is 8 divided by 8? 1, right? So 1, so that's 1 plus the 15. What would that equal? 16. Look at that. We got the answer, right? Well, actually we didn't. Let's try it the other way. Now we got to think of the left to right thing. So multiplication and division and addition and subtraction both get left to right. Right? Left to right. So it's not just multiply first. It's either multiply or divide, whichever comes first from left to right. So if I redid it, I said 8 divided by 4 times 2 plus 15. All right, so let's say now I use this concept. I either multiply or divide, whichever comes first from left to right. The first thing is divide, right? What's 8 divided by 4? 2. All right, now it's 2 times 2 plus 15. What's 2 times 2? 4 plus 15. What would that give me? 19. This is the correct answer. That is the correct answer, right? This would be not the correct answer. Now, most of the time, if you followed PEMDAS without the left or right thing, you would get that answer most of the time for most problems, because most problems don't start with an 8 divided by something, or they don't start with a division operation. That's where the problem comes in. When you start with division and you don't use left or right, then you'll get the wrong answer, right? So that's real important. So whenever there's multiplication division, it's going to be left to right. Whenever it's addition or subtraction, it's going to be left to right. Whichever comes first. You have to go in that order. Does that make sense? Is that clear? And now I'm going to move on to the actual lecture. I just wanted to clarify that. Hunter, I'm still working on your question. I don't have a really good answer yet for you. So it was a great question, so I'm still thinking about it. He asked, how do we know for sure we're doing it right? You know? So somebody says PEMDAS is the way to go.
You don't.
But we don't. I mean, it's like
You don't know. It's just the way you do it.
right. But I was thinking, is there an inherent truth in it, though? Do you know what I mean? And that's what I haven't been able to figure out yet. So I'm still working on it. It's a very philosophical question. You got me puzzled. Now, can you guys help me remember which problem I finished with yesterday or 2 days ago? What was the last one I did? Was it negative 5 parenthesis 2? Okay. All right. So I'm going to go ahead and I'm going to just keep going with the same. I mean, that was problem number 3, right? Am I right?
That was problem number 2.
There was?
Well, if you were asking for the last problem that we did.
All right. Well, I'm going to start at 4. Okay? So I'm going to start at 4 because that's where I thought I was. All right. So here we go. 4 times 3. We're just going to do a lot of problems. So that, and you're going to see, we're going to work through it together, and you're going to start to see, oh, it makes sense now, right? All right, so we've got 4 times 3 minus 2 times 5, where am I? Plus 6 minus 5 times 2. Okay? So, it looks confusing. Are there any parentheses?
Nope.
No. Are there any exponents?
Nope.
No. Okay, great. We've already gotten through those 2. Multiply. Going from left, multiply or divide, going from left to right. Here's 1, right? So what's 4 times 3? 12. Now, can I say minus 2? 12 minus 2 is 10, right? Can I do that? No, I can't, because look, what do I have here? Here's another multiply, right?
Negative 2 times positive 5.
Yeah, so we've got negative 2 times positive 5 is negative 10, right? So I'll have 10. 12 minus 10. All right, then it says plus 6 minus, uh-oh, there's another multiply. What's 5 times 2?
10.
10, okay. Now I've gotten rid of all my multiplies and all my divisions. All I have to do is add or subtract. I'm going to start from the left, and I'm going to move to the right. So here's a subtraction. What's 12 minus 10?
2.
2. 2. Right, 2. And then I've got 2 plus 6 minus 10. What is 2 plus 6? 8. Notice I'm going left to right, right? I'm just keep writing. And then 8 minus 10 is? Negative 2. So my answer is negative 2. Yes?
Wouldn't you, you do 2 plus 6, and then but you still have another subtraction. Like, wouldn't you just bring down, like, you do 8 minus, okay, I see, yeah.
You see it? Does that make sense?
Cool.
Wait, where? Where are you up here?
Yeah, and you do 2, and I put,
so you got 2, and then I brought this 6 down.
I bet you have to do 6 minus 10.
Yeah, but it's 2 plus 6 minus 10. I don't have to do this right now. I'm just once I find this, I'm going to bring this stuff back down, and I'm going to keep going from the left to the right. Does that make sense?
Sort of, yeah.
Does that make sense? I'm not actually sure that it really matters with addition and subtraction left and right, to be honest with you. I was trying to think of an example of when it would matter, but I can't think of one. All right, but that's first. Can I erase? You guys have it?
Yeah.
Yep.
Really? You guys are taking notes, right?
Yes.
Okay. All right, we'll do number 5. We're just sort of slowly get harder, okay? Number 5. Okay, how about this one? 4 minus 3 times 5 minus 7, parenthesis, negative 6, parenthesis, minus, parenthesis 4, parenthesis, minus 5. Okay. Now a lot of times people have trouble seeing the multiply because multiply in algebra doesn't have always a little time sign, right? Everything else does. Well, even division sometimes doesn't. I mean, it has a fraction line, but it doesn't always look like a division sign, right? But adding and subtracting, you always see a plus and a minus. But you don't always see a multiply sign. But whenever you see a parenthesis and a number next to it, it means multiply. So this is a multiply right here. So that is one I have to do. This is a multiply. A number next to a parenthesis is multiply, right? So that's another one I'm going to have to do. This is a number in a parenthesis times, or next to another number inside of parentheses. Parentheses always means multiply. So those are also multiplies. So I've got to go through. I'm going to write 4 minus, now we got 3 times 5. What's that? 15. And then I've got minus. I'm just going to put, I'm just following what's there. And then 7 times negative 6. What's that?
Negative 42.
All right. 7 times 6 is 42. 7 times negative 6 is negative 42, right? So I already put the minus here, right? Do I have to put a minus here, or am I done? This is a minus all by itself. And then 7 times negative 6 is negative 42. So really, it's 2 negatives. Does that make sense?
To the positive.
42. And when you have 2 negatives next to each other, what does that mean?
Positive.
You make it into this gigantic plus sign. It's really fun. You know, you might as well make it fun, right? Whenever you have 2 negatives next to each other, it's a big plus sign. All right, and then I've got another negative here. Oh, and then look, I have 4 times negative 5. What's that?
Negative 20.
Negative 20. So I'm going to put my negative here, and then 20. I get to do this again. Yes!
Yay.
All right, so now I have gotten rid of all my multiplies, all my divides. All I have is adding and subtracting. So what's 4 minus 15?
11.
It's going to be negative, right? It's got to be negative. And then what's 15 minus 4? 11, right, exactly. And then I'm going to say plus 42 plus 20. So I'm continuing to go from the left to right. What's negative 11 plus 42, or 42 minus 11? 31, right? Right? And then plus 20, what's that? 51. There we go. Right? So far, does it make sense?
Yep.
Is this helpful? Is it useful? I know some of you know it, but it's easy to make mistakes in these things. I think I saw almost everybody made some mistakes in order of operations on the homeworks. And it's just because it's easy to do, right? But the more you do it, and who knows, I might make a mistake, so you guys have to correct me if I do, because this is on film, right? You know it. Because if I make a mistake and it's on film, you've got to tell me so that I can say, oh yeah, I planned to do that. I did that so that I could test you and see if you were awake, right? Because otherwise, everybody's going to think I'm stupid, right? I'm doing this in front of millions of people, right? What am I talking about? That was number 5, right? So number 6, right? Yep. All right, here we go. Now we're starting to make it a little different now. 3 plus 2 minus 5, 6 minus 3. All right. Now they talk in Saxon about something called symbols of inclusion. Does anybody remember that? No. Serena, do you want to tell us what it is, sort of? Anybody want to tell us what it is? Sal?
It's like parentheses, brackets, braces,
Yeah.
stuff like that.
So we call them symbols of inclusion. Symbols of inclusion. They can include, brackets, braces. I think those are called braces.
Yep.
They can include brackets. They can include parentheses. They can include an absolute value, right? And actually, I think they can include square roots as well, because anything under a square root sign you would want to include together, right? You want to combine them. So symbols of inclusion could be any of those things, right? So we have symbols of inclusion here. That's the P, parenthesis. All the P's are symbols of inclusions, right? So in this case, in the previous cases, I had P's, I had parentheses, but there was nothing I could do inside the parentheses. So I was done. I had to keep moving down my PEMDAS thing. But here, I do have something inside the parentheses I can do. So these two are included inside these parentheses. I have to do that first. What is 3 plus 2?
5.
All right, so now I'm going to say 4 parenthesis 5, and then minus, I'm going to put my 5 here, 5. Now 6 minus 3 is what?
3.
3. Boom. Oh, that makes it so much easier. Now it's just like the previous problem. 4 times 5 is what? 20. Minus 5 times 3 is? So my final answer is 5. Beautiful. Pretty straightforward, right?
Yeah.
As long as you do that stuff in the right order, it really works quite niftily. Okay, can I erase yet?
Yeah.
Really? You guys are good at note taking. I'm impressed. 6. That was okay. Now to 7. We're getting there. I just want to do a bunch more. It's just so that we're really comfortable with them. And I'm making them harder each time to see if you guys can sort of see it. All right, 2 minus 3 plus 5, parenthesis, minus 6, parenthesis, 4 plus 2, parenthesis, minus 3. Okay.
It's pretty challenging.
I still have, yeah, it looks like a mess. All of these look like a mess to me, right? It's once you do the things in the right order, it simplifies it, and suddenly, oh, I know what 2 plus 2 is, right? You get down to something that's really simple, that you know how to do, right? I just noticed the first thing I see are the P's, the parentheses, and I see there's a bunch of gobbledygook inside the parentheses. I don't want that. I want to combine those things in the parentheses. What is, and I got to go from left to right, 2 minus 3, what's that?
Negative 1.
Negative 1.
Negative 1. What's negative 1 plus 5?
4.
4, right? Negative 1 plus 5 is 4, because that's 5 minus 1. Negative 1 plus 5 is 5 minus 1. So that is 4. So we got negative 3, parenthesis 4. Oh, that looks much easier. Minus 6. What's 4 plus 2? 6. And then minus 3. Okay, so that's looking much easier. Now I'm going to ask myself, are there any exponents? No. Are there multiplies or divisions?
Yeah.
This is right here. What is negative 3 times 4?
Negative 12.
Negative 12. We got it. What is negative 6 times 6?
Negative 32. Well, 36.
Negative 36, right? So you can do that in 2 different ways. You could either write the negative down here and say then what is 6 times 6? Or you could say what is negative 6 times 6? And then you get negative 36 and write minus 36. Either way. You see what I mean? Works either way. And then minus 3. Oh, now this is easy. Negative 12 minus 36. Here's 0.
36.
Here's 0, right? Negative 12 minus 36. Can you see how we're adding them?
Yep, negative.
We're going to keep the negative sign, but we're adding them. So negative 48 minus 3. Okay, we're way out here, negative 48, and we're going 3 more to the left. So you can see how we're adding them again?
Negative 51.
So negative 51, right? Am I right?
This makes a lot more sense now.
This does it? Okay, good. That's what I was hoping. Because you don't want to make mistakes on these. Saxon, I'll just give you a little heads up, Saxon loves these things. They're passionate about these order of operation things.
I know.
And tons of braces, tons of brackets, tons of parentheses, tons of groups, tons of everything, and lots of negatives. And if you get to the point where you get it really well, you can fly through your homework so fast it's not even funny. But if you don't ever get it, I guarantee it's going to be hard every day. I mean, every homework assignment you do. Because they do a lot of these. Okay, are we done? Can I erase it?
Yeah. Running out of space.
Okay. I know this is kind of long, guys. I'm going to try to wrap it up soonish. 8. Well, sort of soonish. Okay, 8. Negative 2. Parentheses. Negative 3. Minus 3. Parentheses. Parentheses. Negative 2. Negative 4. Parentheses. Minus parentheses. Negative 3. Minus 2. Parentheses. Plus 3. Parentheses. 4 minus 2. Parentheses.
Me too.
Oh my gosh, that's like.
Now that's a nightmare, right?
I ran out of problems. Insane.
Right, get it.
Well, then put it on the back of the page. Ah, it is awesome.
Right? Doesn't it? That looks like a mess, right? So I go to my handy dandy PEMDAS thing and I see P's. All right. So are there any things inside inside the parentheses I can do?
Oh,
Yeah.
yes.
What is -3 minus 3? -3 minus 3 is -6, right? You're going to keep the sign and add the numbers. So I've got -2 parenthesis -6, we said, right? Now look, this doesn't have a plus sign here, so that's actually going to be a multiply. What is -2? -2 minus 4.
-6.
You guys all see that? -6? Makes sense? -6. All right. Now we got a minus sign. And then a parenthesis again. What is -3 minus 2?
-5.
-5.
Do you need it in parentheses then?
Uh,
Because as I always told you didn't unless it's multiplication.
You don't need parentheses. I could just write it like that, -5, and I see my two negatives and make it into a positive, right? I could do that. Or I could do it like this. It doesn't matter, either way. If you have a negative and a parenthesis and a negative, it's also two negatives together, and you can make that into a positive. You use the parenthesis as part of your positive signs. All right? But we'll get there. All right, and then plus 3 times parentheses. What's 4 minus 2? 2. All right. All right. So now it's a little easier. Still have this stuff. This is a multiply. This is a multiply with this. So I have 3 things I have to multiply together. I'm going to do the big ones first. What is 6? What is -6 times -6? Positive 36, right? Negative with negative is positive. 6 times 6 is 36. So I've got -2 times 36, positive 36. Then I'm going to keep going. Oh, look, negative and negative. I'm going to make that a plus 5.
Couldn't you do the -2 times the 6 first?
Yeah.
Say
It's
what?
like left to
Yeah, you
right.
do that first.
Okay, I guess I should follow that rule. You're right, I should follow that. All right, so,
It's basically the same.
yes. I mean, it's going to be the same thing when it's in the same group. You know what I'm saying? When it's the same,
Order.
like A times B times C. There's actually, remember you guys learned commutative property?
Yep.
A times B times C is the same as A times C times B. It's the same as C times B times A. It doesn't matter as long as they're all in the same multiplying group, right? You're multiplying all of them. So it doesn't really matter. So I could have done -2 times -6 would be positive 18. I'm not going to change it just because I did it, right?
Then it'll be
Get it?
positive.
That's called commutative property, the way I did it. I decided to do the bigger numbers first because they're all going to be multiplied anyway. What's -2 times 36?
72.
-72, right? So we'll get there in a minute. We'll get there. Let me just finish this. -5 is plus 5. And then plus, what's 3 times 2?
6.
6. Okay, good. So now we have -72. And then we have plus 5. What's -72 plus 5?
-77.
You guys agree? Okay, let me just add my 6 to it.
67.
I know it's going to be, is this going to be positive or negative?
Negative.
It's got to be negative, right? That's got a humongous negative number and a tiny positive number. It's got to be negative. So now I'm just going to subtract 5 from 72 because it's the same number, just the sign's going to be different. So 5 from, so this is going to be 6, that's going to be 12, 5 from 12 is 7, so it's going to be 67. So it's going to be -67. That's these two, plus 6, what's that?
Negative 61.
-7.
-61, right? Right? Because it's going to be, they're different signs, so I have to subtract them, right? When the signs are different and you're adding and subtracting, you subtract the sign, just subtract the number. Okay, good. So that's that one. It's getting hot in here again, isn't it?
Yeah.
Maybe it's worth putting on. Nate, would you turn on the air conditioner so that it's not too bad? All right, we're almost there, guys. I know, almost there. I just have like, can I do 2 more? Can you hang in there for 2 more?
Wait.
Really? I know this is
Write all these down.
Yes. That would be fine.
2 more.
Because
Sure.
we don't have space. Because I've done everything except for like one of them. I did
Oh, okay. Don't worry. We'll just write the next one.
Well,
down.
that would be fine.
Not. Write this one down because this one I'm getting them hard, making them harder on purpose. So now this one is going to be a little different. 5 parenthesis -5 plus 3 parenthesis plus 7 parenthesis -5 plus 9 parenthesis plus 2 all over
Oh.
4 minus 2 plus 3 plus 5. Alright?
Does that mean divide eventually?
Every fraction is a division problem. That means this line here is a division line. So whenever you see that line, it means this divided by this. This divided by this. This divided by this. Right? You can think of this long line as a long division line. Division sign, right? A long division sign.
Just write it down.
Right? So the way you do this is you do the numerator first, and then you do the denominator. You kind of have them separate, and then at the end, once you've simplified the numerator and simplified the denominator, then you work it as a fraction and see if you can simplify the fraction, right? So the first thing I'm going to do is my numerator. I'm going to go 5 times, inside my parentheses I have -5 plus 3, which is?
-2.
It is -2. That is correct. It's got to be negative because that's a bigger number, right? I mean, 5 is bigger than 3, so the negative is going to win. So you're going to be negative, and then 3 from 5 is 2, so there's the number. And plus 7 parentheses. -5 plus 9 is the same as 9 minus 5, which is 4. Plus 2. Okay, all over. Okay, what's 4 minus 2? 2, right? Plus 3 plus 5. Plus 3 plus 5. See, I don't even need these parentheses. I'm even going to take them off. So, all right, I'm going to just keep going this way. 5 times -2 is? -10. Okay, plus, what's 7 times 4?
28.
28. What's plus 2? Plus 2, right? Okay, all over. Oh, let's do this. What's 2 plus 3?
5.
What's 5 plus 5? 10. Okay, we've simplified the denominator. We just got one more step to do. What is 28 minus 10? 28 minus 10.
18.
18, right. What is 18 plus 2? 20, right? 20 over 10. Ah, now we're down to a fraction. Now we can work it as a fraction, right? We got a simplified thing. We just have to simplify it. They both have zeros at the end, right? So what can you do? Those zeros can cross out.
It's basic.
It's basically 2 over 1, which is 2. You got it.
That big problem went to 2.
So next time when you go, like eventually when you start dating, right? When you start dating, you have a date, and you go to the ice cream store. You say, I would like to buy, let me think, the number of ice cream cones I'd like would be 5 parenthesis -5 plus 3 plus 7 parenthesis -5 plus 9 parenthesis plus 2, all divided by 4 minus 2, all in the inclusion, I mean symbol of inclusion, plus 3 plus 5, please.
And then the cashier is a smart math, and he's like, oh, that's 2 codes, please.
Yes, exactly. Right? Everybody will know what you're talking about.
That's weird.
Right? So I think I can stop there.
Yes.
Does that feel good? I think you guys have it. I don't want to go.
Yeah, my brain's getting tired.
All right, so that is it for the lecture.